In 1993, three engineers met at a Denny's restaurant in California. Their names were Jensen Huang, Chris Malachowski, and Curtis Preem. They believed that computers were on the verge of a major change. Personal computers would soon go beyond spreadsheets, documents, and basic office work. They would become machines for gaming, entertainment, and three-dimensional experiences. However, there was one problem. Almost everyone in Silicon Valley recognized the same opportunity. Dozens of companies were already designing graphics chips, and more would soon join the market. Some had more funding, others had better connections, and nearly all of them thought they would lead the future of computer graphics. The three engineers named their new company NVIDIA. Initially, there was little reason to think it would last. NVIDIA released its first product, the NV1, in 1995. It was ambitious, combining graphics, audio, and gaming functions in a single card. But the chip was designed around a technical approach that diverged from Microsoft's developing DirectX standard. The market was choosing one direction, while NVIDIA had chosen another. Its technology quickly seemed like a complex solution to a question no one was asking anymore. Years of work were at stake, and the young company was running out of time. This was the kind of moment that can quietly destroy technology companies. There's no loud crash, no packed courtroom, and no executive led away in handcuffs. The product simply fails, investors lose patience, and employees move on to other companies. But NVIDIA changed its course. Instead of sticking to its original idea, the company abandoned it and created a new chip that fit the market emerging around Microsoft Direct 3D technology. The outcome was the Riva 128. Released in 1997, it shipped 1 million units in its first 4 months. NVIDIA had not taken over the industry, but it had survived its first brush with failure. That survival taught the company a key lesson in technology. Being early isn't enough, being smart isn't enough, and even having a powerful product isn't enough. You must invest in the future that actually materializes. NVIDIA was now ready to make a much bigger investment. By the late 1990s, computer gaming was big business. The games went from flat images to complex three-dimensional landscapes. Every shadow, every explosion, every shimmer on a screen, and every motion character took many, many computations. The computer's brain could do many things, but not that kind of math, many, many times over at once. Graphics chips could. In 1999, NVIDIA introduced its GeForce 256. It marketed it as the world's first graphics processing unit. Graphics processing unit sounded like marketing, but it signaled a profound change. The graphics card, once just a small box tacked on to provide visual output, was increasingly seen as a specialized processor in its own right. NVIDIA timed its introduction perfectly. As PC gaming exploded and video game graphics grew ever more demanding, consumers increasingly paid hundreds of dollars for new graphics cards and replaced them every few years to enjoy games in ever more detailed landscapes. To consumers, NVIDIA sold faster frame rates and more realistic worlds. But in doing so, NVIDIA was financing something bigger than just gaming. Each iteration of graphics cards brought experience in a new form of computing. Parallel computing, breaking vast problems into millions of smaller tasks and solving them all simultaneously. This capability had been honed for creating digital imagery, but NVIDIA had long seen how it might also apply to scientific research, engineering, financial modeling, and medical innovation. Any problem that involved crunching numbers and required a vast, unified processing capability. This prospect, however, was missed by most of NVIDIA's customers. They saw a product that improved their games. NVIDIA saw a new computing paradigm. The company had also made a critically important decision. NVIDIA was fabless. It designed its chips. Manufacturing partners, such as Taiwan Semiconductor Manufacturing Company, TSMC, would execute the extraordinarily costly process of physically building them. This allowed NVIDIA to focus its resources on chip architecture, software, and product development, and to connect its destiny to the global supply chain that made massive scale possible, but that also presented its own vulnerabilities. By the early 2000s, NVIDIA was a household name in gaming. The technology powered Microsoft's original Xbox game console, and GeForce became one of PC gaming's top brands. But when it came to Wall Street, NVIDIA was still largely a gaming company. Its progress was measured in the sale of graphics cards, the upgrade cycle, and its position relative to rivals in the gaming industry. Then, NVIDIA embarked on the development of a software platform that would transform its hardware into something far more valuable. It was called CUDA, and for many years, most of the world underestimated what that was going to mean. The key strength for NVIDIA actually proved to be its anonymity. Back in the pre-CUDA era, getting a graphics chip to do general-purpose computing was a nightmare. Computer scientists would awkwardly wrangle scientific algorithms into the tools that draw computer images. With CUDA, scientists got a more direct route. One might use NVIDIA GPUs to simulate molecules. An engineer might design physical models. An investment bank could crunch mathematical workloads, and researchers could sift through immense datasets. The GPU was breaking out from its role as the core of a gaming machine, but there was no guarantee developers would follow. Setting up a software ecosystem is expensive, painstakingly slow, and relies on developers picking up new skills, teaching them, companies entrusting their new applications to them, and existing software being ported. The payoff was not until the ecosystem became robust enough. Years went into nurturing that ecosystem through NVIDIA libraries, developer tools, support documentation, and grants to scientists. More applications that relied on CUDA meant a better reason to buy NVIDIA hardware, which in turn meant new generations of NVIDIA hardware capable of accelerating CUDA's software even further. Chip and software reinforced each other. Then, in 2012, an event that occurred during an academic competition revealed how powerful GPUs can be when harnessed for artificial intelligence. An ImageNet image recognition competition that year was decisively won by an AI model called AlexNet, which had been trained using graphics processors. It turned out that the pairing of neural networks of the deep variety, massive datasets, and GPU computing delivered a significant breakthrough in machine learning. For the world at large, this event was the esoteric triumph of some academics. For NVIDIA, it was a definitive confirmation. The parallel processing technology developed to churn out millions of pixels for video games was extraordinarily well suited to building giant artificial neural networks. Both required massive amounts of calculation, all of which was made faster by parallel processing. NVIDIA continued to invest deeply into AI. It developed specific hardware chips, built new and faster interconnects between the chips, accelerated key software libraries, and began offering entire AI computer systems, the DGX series. The chip company had evolved beyond selling discrete silicon chips. It was selling a complete ecosystem, from chips to high-speed networking, all supported by years of tools and expertise around its CUDA software platform. Anyone could still build a faster chip, but copying an entire ecosystem of millions of developers was a more challenging prospect. NVIDIA's biggest asset ended up being its invisibility. By the time the world understood the significance of AI, NVIDIA's hardware was deeply embedded within university and corporate research labs, on public cloud provider servers, and as the engine behind the most important AI software platforms and models. It was a matter of building and paving the road, then waiting for the traffic to appear in a moment that seemed to happen almost overnight. In November 2022, OpenAI launched ChatGPT. All of a sudden, tens of millions of people could experience generative artificial intelligence for themselves. AI was no longer some kind of remote research laboratory project hidden inside walls. It can write, summarize, translate, produce pictures, generate software code, and reply to queries in seconds. So for nearly every big technology business on the planet, a chilling, similar thought dawned. AI was going to be the next major computer operating system. Anyone failing to get ahead risked their decades-old enterprise going belly up. Google, Apple, Microsoft, Meta, Amazon, and hordes of tiny, ambitious tech firms began throwing trillions of dollars at AI infrastructure. All of this machinery required computing power. and most of the world's enterprises wanted their computing power to come from NVIDIA. The firm's data center graphics processing units were becoming indispensable for developing all the complex new AI systems. The company's software layer, CUDA, provided an established framework, while its high-speed networking interconnect technology was essential for tying thousands of individual chips together within a data center's giant computer clusters. Graphics card company, now industrial machinery provider for new gold rush NVIDIA's $7.1 billion acquisition of Mellanox back in 2020 to develop a high-speed networking division, also seemed like a genius stroke. It made sense to buy such connections as AI systems became bigger and more complicated and could no longer depend on a single powerful chip. Modern AI needs enormous, dispersed computer clusters to behave like a single vast machine, and NVIDIA had the right processors, networking technology systems, software, and a clear pipeline to create the system from scratch. And its revenue started moving. By early 2023, NVIDIA was pulling in $7 billion in quarterly revenue, but by the final quarter of its fiscal year, it topped $22 billion. That's an astronomical growth rate. The entire market just flipped on its head in 3 months, and there's no going back. One competitor executive said of the NVIDIA surge, "Every enterprise suddenly wants an AI model, and everybody that's building AI models needs NVIDIA." The company's shares soared. Jensen Huang, NVIDIA's co-founder and CEO, instantly recognizable to techies from his trademark black leather jacket, quickly rose to become one of the world's most famous tech CEOs. Analysts who a few years ago focused on NVIDIA only in the context of the video game business started saying the company was a definitive infrastructure of the age of AI. The growth did not end there. Last year, NVIDIA had nearly $216 billion in revenue from its data center unit alone. Its growth continued with NVIDIA having announced an expected revenue of more than $42 billion for its 2025 fiscal year. In the mid-2010s, few would have guessed that NVIDIA, whose graphics cards helped enhance the visual realism of video games, as well as perform some basic computations for scientific and medical research, would eventually sell one of the most strategically important pieces of computing infrastructure in the world. But there's a common truism about gold rushes. Those selling the machinery often profit the most, and not just those mining the precious metal. NVIDIA was selling the machinery, and pretty much all the major companies chasing a piece of the artificial intelligence market lined up to purchase it. NVIDIA's rapid ascendancy could easily be mistaken for an overnight phenomenon. It was anything but, although the ascent itself was meteoric. It was built upon nearly 3 decades of groundwork. The Riva 128 kept the company afloat. The GeForce carved out its consumer dominance. Gaming provided the funding for years of chip design, while CUDA drew developers to the platform. Academic researchers recognized the GPU's potential to power deep learning, and Mellanox amplified NVIDIA's influence in data center networking. The arrival of generative AI unified these separate investments into a potent single platform. That platform was ultimately NVIDIA's true product. A company purchasing an NVIDIA system wasn't just buying silicon. They were buying into an ecosystem, a convergence of software, libraries, networking capabilities, developer expertise, and infrastructure that had been meticulously assembled over time. This integration is what made NVIDIA so formidable. While a rival could design an equivalent chip, it's a vastly different undertaking to compel an entire industry to overhaul its software stack. Yet, even kings are not immune to peril. NVIDIA relies on key manufacturing partners and can lose market access through export restrictions on high-end hardware. Other tech companies are pursuing their own AI processors, and competitors are seeking cheaper alternatives. The AI boom is contingent upon ongoing and substantial investments in data centers. Should these investments taper, or if the revenue generated by AI cannot justify the cost, or if more efficient technology reduces chip demand, NVIDIA could face expectations nearly as stratospheric as its success the price of becoming Wall Street's darling. When the market expects you to shape the future, simply meeting expectations won't suffice. You must consistently deliver the previously unthinkable. However, NVIDIA's saga holds a larger lesson than its market cap. The company succeeded because it prepared for a future long before it became evident. It developed CUDA when the market for GPU computing was nascent. It nurtured relationships with researchers before AI became a corporate imperative. It dedicated years to transforming a gaming chip into a versatile computing platform. NVIDIA didn't merely stumble into the AI revolution. It helped build its foundation. 3 decades after 3 engineers convened in a California restaurant, NVIDIA sat at the heart of the technology world, not because it flawlessly predicted every shift, but because its first ambitious concept nearly foundered, and the company pivoted when reality demanded it, while holding fast when a bold gamble paid off. The entity that once struggled for relevance in graphics had ascended to become the AI titan of Wall Street. This is the Noir ledger, where every fortune leaves a paper trail, and every empire begins with a bet no one else can see.